Hello guys, today I'm going to talk to you about an intro to physics. This is going to give you basic understandings of position time graphs, velocity time graphs, the relationships between them both, acceleration, velocity, etc. This isn't really going to teach you much about them. This is just going to show you graphs and how certain lines on the graphs show you certain data. Hello, today I'm going to be talking to you about the position time graphs versus velocity time graphs in physics. This is still a little bit of a new concept to me, but I am going to try my best to explain it to you. First, we're going to look at position time graphs. Let's say we have a line that goes something like this, an object that is trying. This is supposed to be a straight line, but I can't really draw that good of a straight line. It's the best I can draw. So let's say we have an object that is traveling in a straight line. We call this a constant slope. It is moving a certain amount of meters every second. This will be constant. Because it is a linear line, it will be, the speed will be the same. It will have a constant speed. The way you represent this in a velocity time graph is a straight line that would, if it was on a position time graph, this would be no motion. But because this is on a velocity time graph, it means it is moving at a certain speed for X amount of time. It's moving until the time that it shows on the bottom. Let's do another one. Let's change up the colors. Let's change up the colors real quick. Now let's say we'll try here. Let's say we have the same thing over here, but it was accelerating. Now this is a certain type of graph called accelerating graph. What this will look like, let's try and imagine it. First, you're starting off in the bottom at 0, 0, right? Because it's the center, you're not accelerating at all. And then, well, you get a little faster because you're at 1 meter per second or something here. So then you would be, say like right here, and you would slowly be getting faster and faster and faster. You'd be skyrocketing that way. Forgot to draw the arrows. Anyway, this is an accelerating away graph. The difference between an accelerating away, this is positive acceleration. The difference between positive acceleration, or just normal accelerating, and decelerating, or deceleration graphs, or like negative acceleration, is a negative acceleration graph, but both of these type of graphs are going to try and reach the center right here. They're going to try and reach zero movement. Okay, let's try with a different color this time. Let's try pink. Nice, it's not very visible. Let's try brown, for example. In a decelerating graph or a negative acceleration graph, what would happen in the velocity time graph would be it'd be getting closer to 0 because he's decelerating. He's trying to get closer to 0. He's not gonna try and go away from 0. He's not gonna get faster. Now this, let's say it's -5. This will be 0. This will be +5. So what happens is he's trying to get to 0. 0 means no motion. It means he's not moving at all. This and this means he's moving, but he's moving at a certain direction. How this would be shown is, well, let's think it about. Like, starting at top, let's just say he's starting at the top, and he's moving closer and closer. So -5 meters per second. That means he is moving closer. It's about that much, right? Let's say this was 1, this was 1 second, right? That's like -5. And so what'll happen is he will be going slower and slower until he reaches no time. So it'll look something like that. Now this is deceleration away, or towards, you would say. Or, yeah. So that's your little crash course on it. Now let me try and explain this to you in a different manner. Let's just move all of these real quick. Now let's look at something a little bit more basic, or a little bit more complicated, if you will, for some. Let's say it was a little bit of a normal graph. We'll say he was accelerating for a little bit, and then he stopped, and then he curved. Curve. That's a curve, by the way. right? So how would we represent this in a velocity time graph? Alright, let's break this down into parts, first of all. 1, 2, 3, 4, and 5. Alright, so let's look at 1 second first. From 0 to 1 second. Wait, actually 1, 2, 3, 4, 5. Alright, from 0 to 1 second, he is accelerating. He is moving at, let's say, 1 meter per second. We'll go 1 meter per second here. He's moving 1 meters at 1 second. So that would be 1 meter per 1 second. 1 meter per second. So let's say this was 1, this is 2, this is 1, this is 2. So let's start the graph over here. Right here. Next, he's also moving again at the 2 point. Right, so this is 2 seconds. Still moving the same way, so that's going to be another one. Right? And then we have something a little bit odd. So he's not moving, no motion. How you would represent this, if you know for sure that it's accelerating, then it's going to be a curve. But if you don't know, like for in this instance, you don't really know if it's accelerating. If it's not accelerating and it just drops, like he turns direction or something, it would just be a drop. So it'd be like a 90-degree angle, kind of. And then you have 3 seconds, 4 seconds, also the same, until 1, 2, 3, 4 seconds. So it'd be the same until then. 5 seconds, we see something a little bit more peculiar. Now he's moving downward in a slope type to manner. Well, slope is not actually like a slope, but it's like a curve, kind of a parabola, if you will. Now let's think about it in a fascinating kind of way, if you will. At first, he is moving, let's say, -5 meters per second, because if you were to see this is extremely fast. He's going almost linear, right? So that's got to be -5 or so. It's got to be extremely fast, and he's gradually getting slower and slower in this deceleration process. So how you would represent this was, this is another point, he would be getting slower. So eventually he's going to reach this. But because, you know, he's decelerating, because it's a curve here, it is going to be a slant. Now this slant shows something pretty interesting. Like, now that I showed you in the previous one, the accelerating was accelerating, and how this would be shown was kind of like this, right? Now, if you have the same thing, but if you were getting closer, let's say you were moving back, right? You're trying to get to no motion, no movement at all. You were standing still. If you were, like right here, this is what we would call instantaneous velocity. If you were standing still, you would have no motion. You wouldn't be moving. It'd be like a chair, right? The chair at one moment would be not standing. It would just be standing still. It wouldn't be moving. You wouldn't see a chair walking, would you? So how you would represent this is you start off high, and he's moving extremely fast here. So you're going to drop down, and then you're going to kind of curve down a little bit, right? So this is basically the same thing. This is just like, you know, a sort of easy, like it's a sort of slow deceleration. This is pretty much the same thing as this, except it is fast. It is going, it's almost shooting up. It has less space in between this. If you see this and this, ton of space. Here and here, not a lot of space, right? I mean, that means this is decelerating at a faster pace, and you can see that over here. Now, if you see this, let me change colors here so you can see it. If you see this right here, and this, let me change this color. This, and this. You're gonna spot the similarities extremely quickly. In this one, you're getting the same type of curved motion. In this one, you're getting the same type of straight line. Only this one is a little bit steeper. This one's a little bit less steep. easygoing, if you will. This one is pretty much the same almost. I mean, it's just decelerating. So what would be happening in this scenario is you'd be going 1 meter per second, let's say, change colors, 1 meter per second, so it'd be going kind of fast. You know what we'll do? We'll just, we'll try and draw it. We'll try and draw the position time graph without any information whatsoever. Minute. Okay, let's try and draw it here. Now we see he's moving at 1 meter per second in the beginning, so that means he has to be moving. Let's let us cut a little part of it out. Boom, boom, and boom. Right, okay. Let's say he starts at 0, and he will go up. Actually, this one is supposed to be starting from 0 also. But he's going straight up, because you don't know if he's accelerating there or anything like that. So if he was accelerating there, then it would be this. But no, he's not accelerating, so I suppose it would be this way. Never mind that. Alright, so you see that he's starting at the center, and he's moving 1 meter per second. He instantly shoots up to 1 meter per second here, at 1 second. At 2 seconds, still at 1 meter per second. I mean, he's still traveling 1 meter per second. Honestly, we will go right here. Still traveling 1 meter per second, right? So, I mean, he only drops after 1 meter per second. Imagine this is deceleration. It would be slow. So it wouldn't really account to this. It's kind of like an open circle. Right, so it wouldn't count this, it would be counting everything after this. Think of it that way. So it's still traveling 1 meter per second. Now you have 3 seconds. 3 seconds is right about here. At 3 seconds, whoa, he just drops down to 0 all of a sudden. That means he's got to be moving still. And then he's still there, still moving still until the 4th second. And then he drops all the way down at 5 seconds. Now this means he's got to be like fast right here. Oh, it means he's got to be kind of fast, or he's got to be like that a little bit. And he's getting slowly, he's going up and up and up, which means he's got to be slowly coming back towards the center. So if this was an open arrow, this would also be an open arrow, like so. Anyway, that's a little bit to you about acceleration, deceleration, position time graphs, velocity time graphs, etc. See you in the next video.